Hi, everybody. This is Dr. Nigro with a Physics Fundamentals screencast. This one is looking at free fall. All right, so free fall is defined as an object in motion under only the influence of gravity. All right, now gravity is a fundamental phenomenon. All right, on Earth, gravity has a specific value. All right, and it's an acceleration value because when an object falls or is thrown up in the air, it changes its velocity because of the pull of gravity. All right, so on Earth, the acceleration due to gravity is negative because it pulls towards the Earth, so it always pulls down 10 meters per second squared. All right, now some instances in the worksheets or online, gravity is given the value of negative 9.8 meters per second squared. I tend to work with 10 just because it's easier mathematically, but if you wanted to use negative 9.8, that would be fine too. Just make sure you remember your answers might be slightly different than mine. All right, now when we talk about free fall, there's really three different options. All right, an object can be dropped. All right, and if an object's dropped, it moves towards the surface of the Earth. Its initial velocity is going to be zero because all you're doing is dropping it. All right, once it is released from your hand, it is under the influence of gravity. So gravity pulls down on the object at 10 meters per second every second. So it speeds up as it falls towards Earth. All right, the velocity value will be negative because it's going down, right? And our acceleration value is always negative. So those two negative signs tell us they're working together, which is why it speeds up. All right, now there's a formula for this. We use y because we're talking about vertical motion here. All right, because that initial velocity is zero, we just say that that change in position is equal to 1/2 acceleration of gravity times time squared. All right, so it's a simplification of our delta x formula. All right, again, we're putting a y in there because it's vertical motion, and we've dropped that v initial times time portion because v initial here is zero. All right, so that's if you drop it. All right, another option is to toss it up into the air. So let's say you have a ball and you give it a certain amount of velocity and toss it up into the air. All right, so we're going to have a velocity value initially that you will provide with your arm or stick or whatever you're using to move the object up. All right, once you release it, it's under the influence of gravity. All right, and when it reaches its maximum height, that final velocity is going to be zero. All right, so if you think about it, when you throw something up in the air, it slows down as it reaches the top. All right, and that makes sense in terms of our signs. We're going up, so the velocity value is going to be positive, but gravity is always negative, so our acceleration value is negative, so they work against each other as the object moves up into the air. All right, now to find that maximum height, you are going to have to include the v initial part this time because we do have an initial velocity, and then we use the 1/2 at squared. All right, and again, this gravity, the acceleration value. All right, and then last, an object that you throw up and then you allow to fall back down. We call this up and down. All right, so your object is thrown up into the air with a certain velocity and then comes back down and you catch it at the same height at which you threw it. So we're going to give it some initial velocity just like when we tossed it up, and it's going to have some final velocity once it lands in your hand. All right, assuming the height that you throw it and catch it is the same, then these values numerically will be the same, but they will have different signs. All right, initially our velocity values are positive because we're going up, and then we come back down, those velocity values become negative because we're going down. All right, as the object moves up with that positive velocity, gravity is still negative the whole time. All right, so as you go up, your velocity value is positive, your acceleration value is negative, so you're going to slow down. Right, as you come down, Your velocity value is negative because of the direction of motion. Your acceleration value is still negative. So this is where you're going to speed up. All right, we're going to be using the same formulas that we have for our acceleration problems. We're just going to be putting in gravity's value for acceleration. All right, one other thing to keep in mind is time. All right, there are two versions of time. There's the total time, that's up and down. And then there's what we call the half time, that's just up or down. All right, so the total time, if you divide it in half, that'll tell you the time it takes to reach the maximum height. So this is at t1 half, and when you're up here, your velocity value is 0. So for just a millisecond, when it reaches that maximum height, the ball is not moving, 0 velocity. All right, now let's go down and try some of these problems. All right, I tend to try to identify the problem as a drop problem, a toss, or an up problem, or an up and down problem. All right, so a student drops a water balloon from the roof of ABRHS. So that tells me this is going to be a drop problem. All right, how long does it take the balloon to fall 25 meters from the roof to the ground? All right, so we're going to have V final, V initial, acceleration, time, and change in position. Why? Because again, we're vertical. All right, what do we know? We know the change in position is 25 meters. All right, if this is a drop problem, then my initial velocity is 0, and my acceleration due to gravity is negative 10 meters per second squared. So I actually know some information. All right, so the first part wants me to find this time. All right, so let's see. The change in position is V initial times time plus 1/2 AT squared. And because V initial is 0, this is going to go away. So we'll have 25 meters is equal to 1/2 negative 10 meters per second squared times t squared. All right, now I can already see a problem. I see something I've made a mistake. If I continue my math this way, I'm going to end up with negative 5 times t squared. I'm going to divide the negative 5 over, and I'm going to get a negative value. And then I'm going to try and take the square root of that negative value. Well, that's not going to work because that's not allowed. All right. One thing I should keep in mind is because the object is moving down, this value here, the delta y should be negative. All right. So if I put my negative sign in there, that's going to fix my sign issue. All right. So then I complete the math and I find the time it takes to fall those 25 meters is 11.2 seconds. All right. Now it wants to know, well, what was the balloon's final velocity just before it hit the ground? All right, so I can just use my V final equals V initial plus A times T formula here. My initial velocity was 0. My acceleration was negative 10 meters per second squared because of gravity. And I just found that the time it took to fall was 11.2 seconds. So my final velocity is going to be negative 112 meters per second. All right, and again, that negative sign, it's okay because you're moving down. All right, so don't let the signs mess you up. The only thing that can't have a sign again is time. All right, Karen decides to bungee jump off the Golden Gate Bridge. Once she jumps, she is in free fall for 4.2 seconds. What is Karen's final velocity just before the bungee pulls her back up? All right, so we've got V initial, V final, acceleration, time, change in position. All right, so our initial velocity is going to be 0 because she's standing on the bridge. The acceleration will be negative 10 meters per second squared because gravity, and she falls for 4.2 seconds. All right, so to find V final, I'm going to use my V final formula, V initial plus A times T. The initial is going to go away, so that final velocity is going to be equal to negative 10 meters per second squared times 4.2 seconds. All right, so her final velocity right before the bungee starts to pull her back up is negative 42 meters per second. And again, the negative's fine. It just tells us that she's moving down. All right, now how far? So now we want to find the delta y value here. All right, so that change in position is equal to V initial times time plus 1/2 AT squared. All right, that V initial times time part's going to go away because V initial is 0. So we're left with 1/2 times negative 10 meters per second squared times our time, 4.2 seconds squared. So our change in position, once we plug everything in, is negative 88.2 meters. All right. And again, the negative sign is okay because she is moving down. So that is a negative direction. Okay. All right. So those are two examples of a drop problem. All right. Now let's try something else. Sam throws a ball up into the air. So this is going to be an up problem. All right. It takes the ball 2.6 seconds to reach maximum height. All right. So we've got V initial, V final, acceleration, time, change in position. Sometimes I draw a little picture to remind myself what's going on. All right, and I know that up here at maximum height, my V final will be 0. Right, it takes us 2.6 seconds to reach that point, and gravity is still negative 10 meters per second squared. All right, what was the initial velocity when the ball left Sam's hand? All right, so for this one, you can kind of go at it a couple different ways. I just use the V final formula. All right, this time I plug a 0 in for V final. My unknown is V initial, and I'll have a negative 10 meters per second squared times our 2.6 seconds. All right, so I'm going to get 0 equals V initial plus a negative 26 meters per second. I moved that negative 26 to the other side, and my initial velocity was 26 meters per second, all right, which is reasonable. The sign should be positive because the object is moving up into the air. All right, next, what is the maximum height? So my change in position is V initial times time plus 1/2 AT squared. All right, this time I have to include V initial, so I have my 26 meters per second times my 2.6 seconds plus 1/2 negative 10 meters per second squared times 2.6 seconds squared. All right, so I plug everything in and I find that the ball traveled 33.8 meters up into the air. So the positive sign is correct. All right, so that's an example of an up problem. Just keep in mind, you know V final because it's at maximum height, which means it's going to be 0. All right, for our last problem, Surrey tosses a ball up into the air and then catches it. She tosses the ball with an initial upward velocity of 5.3 meters per second. How long does it take the ball to land back in Surrey's hands? All right, so we have V initial, V final, acceleration, time, change in position. All right, so this time we have an object moving up and then coming back down. We can assume it's caught at the same height. All right, so we're going to have an initial velocity and then we'll have a final one. And remember the relationship between these two, that initial velocity is equal to the final velocity just with a negative sign. All right, so I know that if I throw it up at 5.3 meters per second, that when I catch it, it will be moving at 5.3 meters per second, but downward, so it becomes negative. All right, I also know gravity is negative 10 meters per second squared, and that's it. That's all I know. So we want to know how long. So we're looking for time, all right, and we know based on our rearrangements, time is V final minus V initial over acceleration. So we have negative 5.3 meters per second minus 5.3 meters per second divided by negative 10 meters per second squared. So I'm going to end up with a negative 10.6 divided by negative 10, which is going to fix my sign problem. All right, and I find that it takes 1.0 seconds for the ball to go up and come back down. All right, what was the maximum height at the ball? So we want to know what is the maximum height? What is delta y at the top of the throw? All right, now that occurs at the time 1/2, and that is important because you can't use 1.06 because if you do, you're going to get right back to where you started. All right, and delta, the displacement, if you catch it right where you threw it, is going to be 0. All right, so you have to use the half time. All right, so that t1/2 is equal to 1.06 seconds divided by 2, or 0.53 seconds. So that's the amount of time it takes the ball to reach maximum height. All right, and now I can use my delta y formula. The initial times time plus 1/2 AT squared. All right, so my initial velocity was 5.3 meters per second times 0.53 seconds plus 1/2 times our negative 10 meters per second squared times our 0.53 seconds squared. All right, so I plug everything in and I find that the change in position or the maximum height is around 1.4 meters above where I threw it. All right, now if you plug in 1.06, all right, you're not going to get the right answer. So please make sure that when you're asked anything about maximum height for an up and down problem, use the half time, don't use the whole. All right. What was the velocity of the ball just before Siri catches it? So we're looking for V final, and we already said that that final velocity is equal to the initial, just with a different sign. So in this case, V final is equal to negative 5.3 meters per second. Okay. All right, so those are just 3 different examples or different types of problems that you can come into contact with when you're dealing with free fall. Again, if you would like to use negative 9.8 meters per second squared for gravity instead of negative 10, perfectly fine. I just find 10 mathematically a little bit easier. Okay, all right.